We're moving into lesson 5. We're going to be solving exponential equations today. So, hey, good morning. All right, so let's proceed. Well, and I'm just going to do a variety of examples. They're all the same. Some are harder than others, but the idea is the same. So some of these you could probably just do mentally. Okay, so suppose I had 5 to the x equals 125. 5 to the x equals 120. All right, so now some of these you can do mentally, and that's all we're doing today. There are some that you actually can't. You actually need a calculator for. It's impossible to do it. We're only going to be doing the ones that you can do mentally in this chapter, because the ones that you can't do mentally, you need logarithms to do, and we'll learn that next chapter. So for now, here's the strategy. Now, does anybody know the answer already?
Yeah, 3.
It's 3. Okay. But I'm going to show you a strategy. The strategy is this. You want to make the bases match. Now, what's the base? I'll try to explain that to you. This is a base, and this is a base. A base is a number with a power. So like this is 5 to the x. This is 125 to the first power. I'm going to erase that 1, but the point is a base is a number that has a power on it, so that's what I mean by the base. We want the bases to be the same. And usually what you're going to do is you're going to change the bigger one into the smaller one. So it's going to look like this. I'm going to say 5 to the x is equal to 5 to what power? And you just got to think about it. So 5 to the first is 5. 5 to the second is what? 25. 5 to the third is 125. 5 times 5 times 5 is 125. So I'm not solving it yet. All I'm doing is changing the way that this one looks. But don't you agree that the 125 is the same thing as this? So I just changed the way it looked. But now that I've done that, 5 to the what equals 5 to the 3? Well, you can just ignore the bases because I got the bases to match. That means the exponents have to match. And that's the idea. Okay? Now that's something. So those of you guys who did it mentally before I even gave you the answer, you're thinking, well, that's overkill. But there's a reason I'm doing that, because it will help us with problems that are coming up later where it's not quite as easy to do it mentally. So let me give you guys one. So student practice 1. How about 4 to the x power is equal to 256. I'll give you guys a little bit. We want to make the bases match, and usually you're going to make the bigger one match the smaller base. So this is going to be 4 to some power, and after a little bit of calculator work, you'll find out that it's 4 times 4 times 4 times 4. In other words, it's 4 to the 4th power, so it's sad times. X equals 4. All right. So let's go ahead and do another one. I wonder if I can bring my computer back to life. Let me pause my video here. We're going to do more of these today. We're just going to be taking them up a notch, though. Showing you different scenarios that could happen. So here's an odd one that could happen. Okay, that's kind of weird, isn't it? So we're going to learn how to deal with fractions. What were you going to say?
Negative.
Yeah. So what we can do, this is, the bases don't match. They look like they do a little bit, right? Because this is a 5 and this is a 5, but this base is actually a 1/5, right? But we can change that into a power of 5 to a -1, right? So the answer in this case would be -1. So the big question is, how do you deal with fractions? Well, you just make the exponent a negative, and that undoes the fraction, basically. Makes them have the same base. Now, as a further example, suppose I had 5 to the x is equal to 1/25. What do you guys think that's going to be? -2. So Now, for those of you guys that aren't seeing it quite as easily, I'll show my work a little bit. First of all, you guys, based on what we just talked about, you agree that's true, right?
Mm-hmm.
Now, they still don't match, though. But I can turn 25 into a base of 5 if I rewrite it like that, right? It's a lot of work, and so if you can just do it quick in your head like that, I respect that. But now the rule here is you multiply these. So there you go. Cross those off, you get x equals -2. So that's how you're going to deal with the fractions. Now, hey,
What's up?
how you doing, sir? Are you coming in here?
Yeah, because my English class got dropped.
Oh, okay. Well,
So what's up?
Teacher. Anyway, now here's how I do these ones mentally. I actually don't do all that work. That's a lot of extra work. I just think, okay, that's 5 squared in the bottom, right? And it's upside down, so it's -2. Change the sign, right? So that's how I'd encourage you guys to do it too. But just showing the math work there. So why don't we have a student practice 2 there? Suppose I gave you guys the following. How about 3 to what power is equal to 1/27? See if you can figure that out. Okay. So the way I showed you guys last time would have been like this, right?
Yes.
And then 27 is 3 to the 3rd power. 3 times 3 times 3, right? And then using our exponent rule there, drop the bases off. Gotcha. Okay. So that's one thing that you may need to deal with is how to deal with the fractions. Okay. Here's another way you can handle this. This might make more sense if you guys were out there getting a little bit confused on it. Oops, sorry, pen slipped out of my hand. So we're starting here, right? What you can do is you can change that number into a 3 first before you flip it. 3 to the 3rd power, right? And then you can flip it by just changing the exponent to a negative. A little bit less work that way, if that makes more sense. Okay? All right, so let's move along. Another thing we might want to deal with is some roots. So suppose I told you that 2 to the x power is equal to the square root of 2. We're going to have to pull in some old knowledge here. In case you guys don't remember, if you have a number in here, we'll call it b, you're going to have a root here, and you're going to have an exponent here. Okay? So this can actually be written like this. It's a fraction exponent. Remember how the root is the denominator? Shot this from before our winter break there. So now in this case, when they don't have a number here, what number is it? No. It's a 2. It's a square root. Square roots are really for groups of 2 things that are the same, right? And then we also don't have an exponent on the 2. What is it? A 1. So if I wanted to change that into exponential form, it would be 2 to the 1/2 power. And therefore, x equals a half. Okay? In other words, 2 to the 1/2 power is the square root of 2, right? Okay. That was example 3. Let's have you guys try one. How about 7 to the x is equal to the cube root of 7. Yeah, we are. Yeah, we are. You just missed the first example, just kind of like the baseline. Yeah, no, they're exactly where you are. Teach us the third grade. Fourth grade, right? So Cameron, how would I rewrite this in exponential form? 7 to the power of 1/3, right? And then we can drop the 7s out. You know, if 7 to the what equals 7 to the 1/3, then obviously the exponents have to match since the bases match, and we have right. So we've talked about how do you deal with fractions. Basically the same way you would deal with any of them, just make sure the exponent's negative, right? How do you deal with roots? Got to change them into exponential form. So let's see what else I can torture you guys with here a little bit. All right. You could come across a situation like this. Does anybody see what the issue there might be? What's the issue?
The base doesn't match.
The bases don't match, and you can't get them to match, right? Like you can, but you're not going to be able to change the bigger one into the smaller one in this case, like because 9 to the first power is 9, right? And 9 to the second power is 81, so it skipped over it. So something's wrong there, right? So when that happens, what you have to ask yourself, is there a base that we can change them both into? 3, right? I can change the 9 into what? 3 to the second power. Don't forget that little x is still out there though, right? And I can change the 27 into what? 3 to the third. Now they've got the same base. Okay, so sometimes you need to change both sides. So simplifying this, you just multiply the 2 and the x, you get 2x. And once again, we drop out the base. But at this point, this is new. We get to go a little bit further now. So what do I have to do now? Just divide by 2. So we get x equals 3/2. So the point of this problem is to show that sometimes you have to change the base on both sides, which makes for a little bit of an extra step at the end where you still need to get x by itself.
Okay, buddy.
You ready? Student practice. You try that one. So I think a really tempting base to go with on this one is 4, but you can't write 8 as a 4 to a power, right? Because 4 to the first power is 1, and 4 to the second is 16. So the common base can't be 4, because you can't rewrite this as a base of 4. But what you can do is you can rewrite it as a base of 2. 2 to the third power. And you can also write 16 as a base of 2. It's 2 to the fourth power. Okay, so we have 2 to the 3x is equal to 2 to the 4. Drop the bases out and solve for x. You're going to get 4/3. Okay. Right. So that was an example of changing base on both sides. So we've done fractions, we've done roots, we've done changing both sides. Let's take a look at another one. Example what, 5? Yes. Suppose I gave you guys 4 to the power of 2x minus 3 equals 16. It's not that bad, you'll see. It's not that bad. All right, so let's take a look at our bases. The smaller one's 4, right? The big one's 16. Can I rewrite 16 as 4 to the power?
Yes.
Yeah. So we don't need to change both sides this time. That's nice. We just need to change the 16. I'm going to change that into 4 squared, right? So now that I got the bases to match, what do? Just drop out the bases. And you actually end up with just a very simple two-step equation to solve, right? So it's not that bad. It looked ugly. It looked ugly, but it really wasn't that bad. Five halves is our answer. So we'll call that the crazy exponent one. Right? So we've done fractions, roots, crazy exponents, change both sides. Those are all different kinds of scenarios you can come across. Everybody done notes? Let you guys try one.
Is there going to be one with a crazy exponent that we have to change both sides?
Could be. Do you want one?
No.
All right. So, let's see. Suppose I gave you guys 3 to the 4x minus 5 is equal to 27. You guys try that. That's a student practice 5, I believe, right? So we have 27. Now, I can change 27 into a base of 3, right? We've seen that a few times today. So we can drop out the base now, and then we have this equation that needs to be solved. If you solve it, you should end up with 2. Hello. Are you joining us? Okay, cool. Just grab a seat anywhere. All right. So we got a lot going on here, right? So first of all, let's look at our bases. Let's get those bases to match first. I've got 4 and 8. What's the common base? 2. 2. Right, so let's do that first. So we're going to have 2 squared, right? I'm going to put that in parentheses, and I'm going to leave the original exponent out here, right? Equals 1 over the square root of 2 to what power? 3, right? So I got my bases to match at least, okay? Now there's other things I need to do. What do I need to do on the left side here?
Simplify.
Yeah. Now what does that mean?
Substitute to the 4x.
Very good. So you're going to distribute this 2 to both of those. Good. So it's going to be 2 to the 4x minus 6 equals, now let's do something on this side. I can rewrite the bottom as 2 to what power?
3.
3 halves, right? This is my top. There's no number there, so that's a 2. So this is 3 halves power, right? We're almost there. What's one more thing I need to do?
Flip it.
Flip it up, right?
Yes.
So 4x minus 6 is equal to 2 to the negative 3 halves. Drop out the base, and now we've got this. Probably still not happy with this one because we have a fraction, right? What do we do? What have we always done with fractions?
Fractions are fun.
I hear multiply by the reciprocal. You could do that. I've always taught just multiply everything by the denominator. Okay, so so we're going to do times 2 here, times 2 here, times 2 here. So this is going to end up being 8x minus 12 is equal to negative 3. And that way you don't have the denominator anymore. But if you have another strategy you want to use to solve it, that's fine. Just make sure it works, right? So that was just a mean and tortuous problem, but hey. I gave you donuts today, so it's okay.
Oh no, the cheese is just hold it down for a second.
Yeah, it'll be up.
Go.
Oh, yeah, those ones?
Yeah.
They'll be up.
I don't think we-
No. Okay, let's do one more thing before we call it a day. Let's say that f of x is equal to 3 times 2 to the x minus 4. Let's say that. So what does that mean when I say f parentheses 0? Plug in 0 for x, right? So f of 0 then means 3 times 2 to the 0 power minus 4. Now you got to do your order of operations, so what comes first? Exponent. So what does this equal?
Should be 1.
It's 1. And then what do yeah, anything to the 0 power equals 1. Now what is 3 times 1?
1. I mean 3. 1. Right.
So you got to follow your order of operations, right? One more thing. Yeah. Yeah. I'm just reminding you guys of function notation here a little bit.
What does that mean?
So
This man is so confused.
what this means is instead of plugging a number in for x, you're going to set this thing equal to the number, right? F of x is 8, right? So I'm going to replace f of x with 8. Now this has a few other little things that are interesting along the way. What do you guys think I would do first if I want to solve for x?
Oh.
We need to add the 4 over first, right? Get rid of all those outside numbers first. So we're going to plus 4 on both sides. At this point, I'm just kind of relying on your old algebra knowledge here. So now what? Divide by 3. Those numbers have nothing to do with exponents, so just get them out of the way like normal. It's not a pencil in your hand, young lady. What are you doing? Staring at me with those cocked eyebrows with a phone in your hand. All right, so we have 4 equals 2 to the x. And now doesn't that look like what we've been doing today? Right, so now we get the bases to match. What's the common base? 2. And so the answer is? All right, so